Hi everyone, Assalamualaikum. In this video, we are going to continue with volume by shell. Okay. Now we look at example 3 from the previous semester papers. The shaded region in figure below shows the region R bounded by the curve x equals to 2 minus y squared and the straight line x equals to negative y. Determine the volume of the solid generated using the shell method when the shaded region is revolved about the line y equals to 4. Right? Alright, this is the curve x equals to 2 minus y squared. This is the straight line. X equals to negative y. This is intersection point, okay, between straight line and curve. This is region R, okay, before rotation, okay. Alright, so the axis of rotation is line y equals to 4. Okay, this is the axis of rotation. Okay. Using shell method, if the axis of rotation is a horizontal line, okay, so we need to integrate with respect to y. Okay, means we need to use lower limit and upper limit on y-axis. Okay, and then we need to find the radius and height. Okay. Okay, under washer method, we recall back. If we have axis of rotation is a horizontal line, we need to integrate with respect to x, and all must in terms of variable x. Okay. Alright. Under washer method, we have outer radius squared minus inner radius squared, but we doesn't have height. Okay. Under shell method, we don't need to square the radius, but we multiply radius and height. Okay. And under shell method, we have constant 2 pi here. But under washer method, we have single pi here. Right? Alright, after the shaded region here is revolved about this line, so we get this diagram. Okay. This is the cross section of the diagram. Right? Alright, from here, from the shaded region here and the axis of rotation here, there is a gap between the shaded region and the axis of rotation. So, our diagram will have hollow here. Okay? Means that we cannot use volume by this to find the volume. Okay? Alright. So, in this case, okay, this is the diagram from outside. Okay? And dotted line here means inside here we have hollow. Okay? Alright, under shell method, we need to find the radius. Okay? Radius means the distance between the shaded region to the axis of rotation. This is the original shaded region. Okay? This is axis of rotation. So the distance between the original shaded region and the axis of rotation is radius. Okay? Under shell method. Okay? Alright. To find the radius using shell method, okay. Alright, after rotation, we have this diagram, and then now the shaded region here is rotate about line y equals to 4. Okay. So this is our original shaded region. Okay. And this is the radius from here. Okay. And from radius here, okay, the distance between the shaded region and the axis of rotation. Okay, so the axis of rotation, let's say we write 4 here because y equals to 4. Okay, this is the axis of rotation. Okay, and let's say we write y represent the shaded region, the original shaded region. Okay, when we compare 4, okay, means the axis of rotation is on the top of the shaded region here. Okay, means y. Okay, so means that we need to minus from top and then minus bottom here. Okay, means y. Okay, we represent the shaded region equals to y, okay? And we represent the axis of rotation, okay, as 4, okay? Alright, then we minus, because 4 here is the top, okay? And y here means the shaded region is the bottom, okay? Alright, so top minus bottom, okay? So we get radius, okay, equals to 4 minus y, right? Then we can put here, okay, our radius equals to 4 minus y, okay? And then after we find the radius under shell method, we need to find the height, okay? Alright, as I said before, if the axis of rotation is horizontal line, under shell method, we need to integrate with respect to y. And if we integrate with respect to y, the height equals to right minus left, right? So from here, okay, this is the height, okay? This is the right function and this is the left function, okay? So our right function, okay, is here, okay, 2 minus y squared. And our left function here, this straight line, equals to here, okay, equals to negative y, okay. Alright, we write x as a subject, okay, for both functions so that we can subtract, alright. Then we simplify, so we get height equals to 2 minus minus, so we get plus y and then minus y squared, okay. This is our height. Now we done find the radius and the height, okay. Alright, from the previous slide, we find radius equals to 4 minus y and height equals to 2 plus y minus y squared, okay. We recall back the formula under volume by shell. Okay, after we find the radius and height, then we can set up the volume, okay. So volume by shell equals to constant 2 pi and then we integrate radius times height, okay. And then to determine whether we need to integrate with respect to x or with respect to y, we refer the axis of rotation, okay. Under shell method, if the axis of rotation is horizontal line, so we need to integrate with respect to y. So means that we need to use the values, the limit on y-axis, okay. Alright, so from here, okay, this is the original shaded region, okay, before rotation, okay. When we draw a line to y-axis, so we get y equals to negative 1 from the given coordinate, okay, in the original question, okay. So we get y equals to negative 1 and upper limit y equals to 2, alright. So we have volume by shell equals to 2 pi, integrate from y equals to 1 to y equals to 2. Then we replace radius equals to 4 minus y, okay. And we replace height equals to 2 plus y minus y squared, okay. Alright, from here, you can see that all in terms of variable y, okay, including lower limit and upper limit, okay. Under shell method, if the axis of rotation is parallel to x-axis, or in other words, is a horizontal line, all terms must in terms of variable y, including lower limit and upper limit, must on the y-axis, right? Alright, so from here, we can expand and simplify, okay, before we integrate, okay. So we expand one by one, okay. So after we expand, so we get this, okay, y cubed minus 5 y squared plus 2y plus 8 dy. After we expand and simplify, so we get this. Okay, then we can integrate with respect to y. Okay, we integrate one by one because in between is plus and minus sign. Okay, so volume by shell equals to, we still have constant 2 pi after we integrate here. Okay, then we integrate y cube using power rule. So we get y to the power of 4 over 4 minus, we still have constant 5 in front, and then we integrate y squared, we get y cube over 3, and then plus, we still have constant 2, and then we integrate y, we have y squared over 2, and over 2 here, we can simplify with 2 here. That's why we get y squared only. And then when we integrate constant 8 with respect to y, we get 8y. Right? Right, after that, we replace upper limit into variable y. Okay, and then in between must minus. Okay, and then we replace lower limit into variable y. Okay, so we get this. Okay, then we simplify, so we get this. Okay, and volume by shell equals to 63 over 2 pi units cube. Cube here because volume here. Okay, so this is the final answer, 63 over 2 pi units cube. Okay, we can check the answer using symbol lab. Okay, from this point, okay, we done set up the formula of volume by shell. Set up here means we done substitute the radius, the height, and then the lower and upper limit, okay, into volume by shell formula. Okay, so from here we can use symbol lab to calculate. Okay, so we have 2 pi here, integrate from -1 to 2, 4 minus y times 2 plus y minus y squared dy. And then after we press enter, so we get this 63 over pi, 63 pi over 2. Okay. Alright. From here, we can see that our volume is positive value because volume and area always positive. Okay. And then we just leave our answer in fraction and pi. Okay, because it's more accurate compared to decimal. Right? So this is the complete answer, and then from the previous slide, we find the radius and height first. Okay. Coming up next, more examples for volume by shell. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.